Hello, we're going to tackle some quite beefy questions today. There's two of them. They're going to combine all of our knowledge on tangents, normals, chain rule, product rule, and quotient rule, all in two questions. Okay, so be ready for this. So the first question says, find the equation of the tangent to the curve. We've got a complicated looking function there at the point where x equals 5. Okay, so first thing that strikes me about this is that it's a quotient. Okay, and I can see that u equals x. Oops. U equals x. And v equals the square root of 2x subtract 1. Okay, so when I'm using the quotient rule, okay, I'm going to be doing eventually dy by dx equals vu dash minus uv dash over v squared. So I only need to go and find those things. I need to differentiate u first, which is 1. I need to differentiate v. That's not straightforward because it's a function within a function. So at the side, I'm going to do a quick chain rule to work that out. Okay, I'm going to change it into y equals square root of 2x minus 1. Now here, I can say that my function in the function, call it u, is 2x minus 1, different to this u, of course. And y in terms of u is u to the power of a half, because the square root is a power of a half. By the chain rule, what I need to do next is similar to over here, which is I just need to go and differentiate both those things. So I get 2, and I get half u to the minus 1 half. Okay, now this here is actually half u isn't u, is it? It's 2x minus 1 to the to the power negative 1 half. And by the chain rule, what I need to then do is multiply this and this together. Okay, so 2 times a half is really easy. It makes 1, which tells me that this is 2x minus 1 to the power of negative 1 half. Okay, now I've got these things, I'm ready to put them into the quotient rule. So vu dash, okay, now that's nice because it's just 1 times that, which is just square root of 2x minus 1. Minus, now this times this, so it's just 2x minus 1 to the power of negative 1 half, divided by v squared. Now if I square a square root, the square root disappears, so it's just 2x minus 1. Okay. The next thing I need to realize is that I'm going to find the gradient. This is the gradient function. I'm going to find the gradient at this point by substituting x equals 5 into it. Okay. So when x equals 5, dy by dx is the square root of 2 times 5 minus 1. I'm going to do this. I've got a lot of room, so I'm going to do this quickly. So 2 times 5 is 10, minus 1 is 9. Okay, well that's 3 in a second. And I've got 5 times 2x minus 1 again. 2 times 5 is 10, minus 1 is 9 again, to the power negative a half, over 2 times 5 minus 1 again, which is 9. Okay. And when I put that into my calculator, I get 4 over 27. Okay, 4 over 27. So my gradient is 4 over 27 here. So I've got part of, so that's in a different colour, so it stands out. I've got part of my equation of the tangent, which is ultimately what I'm wanting to find. So equation of the tangent is y equals 4 over 27x plus c. And I'm not quite there because I need to find the c. And I'm not going to be able to find the c unless I know the actual coordinates of this point. Okay, so I need to know the y coordinate that goes with the 5. So I put 5 in here, I get 5 over, 5 goes in there again. It's 5 over 3, isn't it? 5 over 3, because it's the square root of 9. So if I substitute those things in to go and find what c is, so over here, I can say 5 over 3 equals 4 over 27 times by 5 plus c. Okay, and rearranging that gives me, what does it give me? It gives me 25 over 27 plus c. Okay, now I've got options here. So actually, y is 4 over 27x plus 25 over 27. Now I've got options here. I could leave it there. It doesn't ask me to put it in any other form. But if I did want to make it a bit tidier, I could times everything, of course, by 27. So I get 27y is 4x plus 25. And I could even put it all on one side and say that, I've got loads of space here, but I could say that 4x minus 27y plus 25 equals 0. Okay, that's quite tidy, but that's fine. I mean, to be honest, it hasn't asked for it, so it's absolutely fine. All right, so there's a lot going into that. There's the product and the quotient and finding the equation of a tangent, all in one question. Okay. The next question are all the other things that we haven't looked at, okay, in that list of topics that I listed at the beginning. So the next question is find the equation of the normal to the curve, okay? So looking at a product next, product rule, okay? So this is my u, this is my v. So u is x squared, v is the square root of 2x minus 1. Already I can see there's going to be a bit of chain rule going on here as well. All right, and I'm going to have to find u dash, which is 2x, and I'm going to also have to find v dash. Okay, now I'm going to have to do a chain rule over here. Ultimately, I'm looking to find dy by dx to give me the gradient of my tangent followed by the gradient of my normal by the product rule. So uv dash plus vu dash is what I'm going to be using eventually, but I need to find this v dash first. So up here in a different color, I'll do some chain rule. Okay, and the chain rule is, here we have square root of 2x minus 1 that I'm trying to differentiate to find v dash. In this case, right, the function in the function is u, and different to this u, as I said before, and u dash is equal to 2. And y in terms of u is the square root of u, or u to the power of a half. So if I do y dash, I get half u to the minus a half. So these two things now will be multiplied together by the chain rule to give me v dash, which 2 times a half, that's quite nice. It's just u to the power minus a half. But u isn't u is 2x minus 1. So it's 2x minus 1 to the power negative a half. So let's put this up here now in red. So we've got 2x minus 1 to the power of negative half. Right, okay, so these can now go into the product rule. So uv dash is x squared, 2x minus 1 to the power of negative half, and vu dash is 2x square root times the square root of 2x minus 1. Okay, now this is eventually going to tell me the gradient of the tangent. Bear in mind, we're not looking at the tangent line, we're looking at normal. So we've got this step first, the gradient of the tangent, x equals 1, which it tells us in the question, is going to be 1 squared is 1. We've got 2 times 1 minus 1, which is 1. Anything to the power, 1 to the power of anything is just 1, isn't it? So that's 1. Then we've got 2 times 1 here, which is 2. And then we've got 1 goes in there, that's just 1. So it's 1 plus 2, which is 3. Okay, that's nice and straightforward as a value. If the gradient of the tangent is 3, the gradient of the normal is the negative reciprocal of that, which I hope you remember is, if this is m, this is minus 1 over m. So in this case, it would be minus 1 over 3. Okay. Right, so we're going to start to write down then what the gradient, the equation of the normal is. So the equation of the normal, y equals minus, let's tidy that, minus 1 over 3x plus c. Now we've got the x value up here. Okay, so to do the rest, to find the c, we have to work out the y value that goes with it by putting the 1 back into the original equation, which tells us what y is. So 1 goes in here, it's 1 squared, that's 1. 1 times 1, which 2 times 1 minus 1, yeah, it's 1. Square root of 1 is 1, so it's just 1 times 1, which is 1. Okay, so 1 goes in here, and we get 1 equals minus 1/3 times 1, add c, and so c is 4 over 3. Okay, and as we did before, I mean, we can put that in and make the values integers. So what we get to start with. I might have to do this in a different colour because I'm going into the purple. So we've got y equals minus a third x plus 4 over 3. That's absolutely fine given the question. It's not asked us to give it with integer coefficients, but we can just tidy it up a bit if we like. 3y is minus x plus 4, and then we can get everything on one side. So we can say x plus 3y minus 4 equals 0. Okay, so any of those three answers is absolutely fine. They're all meaning the same thing. Okay, so there's two, as I said, very beefy questions with lots going on. Hopefully you're able to follow all of that. Any questions, please let me know, and good luck.